We're asked to use the law of sines to solve the triangle ABC if angle A equals 48 degrees, side A has a length of 4 units, and side B has a length of 5 units. Notice here we are given side-side angle. When using the law of sines and we're given side-side angle, there are 3 possibilities. We can have no solution, 1 solution, or 2 solutions. We will discuss this as we go through the solution process. For the initial setup, let's use this triangle here where angle A is 48 degrees and the opposite side, side A, is 4 units. Let's let this be angle B, and therefore the opposite side, side B, is 5 units. Let's let this be angle C, and this will be side C. Let's begin by determining the measure of angle B. Using the law of sines, we have the sine of 48 degrees divided by 4 must equal the sine of B divided by 5. Now we could cross multiply here, but let's go ahead and multiply both sides of the equation by 5 to solve for sine B. If we multiply both sides by 5, we have 5 times sine 48 degrees divided by 4 equals sine B. Now we need to solve the equation for B by taking the inverse sine of both sides of the equation. This gives us inverse sine of 5 sine 48 degrees divided by 4 equals B. When we take the inverse sine of sine B, it simplifies perfectly to B. Now we need to go to the calculator and get a decimal approximation for the measure of angle B. It's important to make sure the calculator is in degree mode, and then we press second sign for inverse sine. We need parentheses around 5 sine 48 degrees to make sure the product is in the numerator. So we have open parenthesis 5 sine 48, close parenthesis for the sine function value, close parenthesis for the numerator, and then divided by 4, close parenthesis for the inverse sine function, and enter. At this point, if we were to get an error, we would know there is no solution or no possible triangle from the given information. We are also round to the nearest tenth. Because there's a 6 in the hundredths place value, we round up. B is approximately 68.3 degrees. So because we found one value for B, we know there is at least one solution. Let's check to see if there are 2 solutions. Remember, the sine function value is positive in the first quadrant and the second quadrant. And therefore, there's an obtuse angle in the second quadrant that also has this same sine function value. Let's find that angle and see if it would work for this triangle. So again, the angle we found on the calculator was 68.3 degrees. Let's say this angle here. To find the obtuse angle in the second quadrant, we sketch a reference angle of 68.3 degrees in the second quadrant, which would look something like this. And therefore the obtuse angle that has the same sine function value would be this angle here. So another possibility for angle B would be approximately 180 degrees, or half a rotation, minus the reference angle of 68.3 degrees. And therefore B could also be approximately 111.7 degrees. To see if we have a second solution though, we need to make sure that the sum of angle B and angle A is less than 180 degrees. If it's greater than or equal to 180 degrees, we don't have a second solution. If it's less than 180 degrees, we do have a second solution. Remember, the sum of the interior angles of a triangle is always equal to 180 degrees. Well, because 111.7 plus 48 is less than 180 degrees, in this case we do have a second solution. So when B is acute, or 68.3 degrees, the triangle looks something like this, where B is an acute angle. But if we swing side A to the left, notice how B is now an obtuse angle, which would measure 111.7 degrees. So we do have 2 solutions here. We need to solve both of these triangles. For the next step, let's find the measure of angle C in both triangles. So for the first triangle, where all the angles are acute, angle C is going to be approximately, because this angle is rounded, 180 degrees minus the 2 interior angles that we already know, so minus 48 degrees minus 68.3 degrees, and therefore C is approximately 63.7 degrees. And now for the second triangle where angle B is obtuse, we have C is approximately 180 degrees minus the two known interior angles, which is minus 48 degrees minus 111.7 degrees. So for the second triangle, C is approximately 20.3 degrees. Now for both triangles, we need to find the length of side C. Going back to the first triangle, let's be sure to use the angle of 48 degrees since this angle is exact. Let's begin with the sine of 48 degrees divided by 4 must equal the sine of 63.7 degrees divided by C. And now we could cross multiply. Let's go ahead and multiply both sides of the equation by the least common denominator, which is 4C. Simplifying before multiplying, 4 divided by 4 simplifies to 1, giving us C sine 48 degrees equals, on the right side, C divided by C simplifies to 1, giving us 4 sine 63.7 degrees. Solve for C, we divide both sides by sine 48 degrees. Simplifying, sine 48 degrees divided by itself simplifies to 1. And now we'll go to the calculator and get our decimal approximation for C in the first triangle. Again, we need the numerator in parentheses. We have open parenthesis 4 sine 63.7 divided by sine 48 degrees, and enter. To the 10th place value, C is approximately 4.8. And now we need to find C in the second triangle where angle B is obtuse. We'll begin with sine 48 degrees divided by 4 equals, in this triangle we have sine 20.3 degrees divided by C. Again, we multiply both sides by 4C. Simplifying before multiplying, on the left, we have C sine 48 degrees equals, on the right, we have 4 sine 20.3 degrees. To solve for C, we divide both sides by sine 48 degrees. Simplifying, sine 48 degrees divided by itself simplifies to 1. So now we know C is equal to this quotient, which we'll go back to the calculator to get a decimal approximation. The only difference is we need to change 63.7 to 20.3. So if we press second enter, it brings up the previous entry, and we can now edit the entry by using the arrows and overriding any value we want. So let's replace 63.7 with 20.3 and press enter. And to the 10th place value, we have C is approximately 1.9. So in the second triangle, C is approximately 1.9. Let's go ahead and summarize the results. We know we have two solutions. So for both triangles, we know angle A is equal to 48 degrees. In the first triangle, angle B is approximately 68.3 degrees, and angle C is approximately 63.7 degrees. In the second solution, angle B is approximately 111.7 degrees. Angle C is approximately 20.3 degrees. And then for both triangles, we know A is equal to 4 units and B is equal to 5 units. But for the first solution, or first triangle, C is approximately 4.8. And for the second solution, C is approximately 1.9. I hope you found this helpful.